Go with section 5.3. To begin with, I want to ask you a question. Here's a cell phone plan, Joe Schmo's plan, and it costs $30 a month, and the first 100 minutes are free. So whether you use 0 minutes or 99 minutes, you're still paying $30 for that first 100 minutes. After the first 100 minutes, he charges you 10 cents per minute. So the question is, does slope-intercept form help you model this situation in the real world? If you look at the graph below, you'll see that it actually has this strange shape to it. The graph is flat for a while, and then it becomes a line that has a slope of 10 cents per minute onward and upward. Slope-intercept form doesn't really help us here, and this is why. We know the slope of that line, the red portion of the line, is 10 cents per minute. But we don't know the y-intercept for the line, and we can't just extend the red line all the way back until it hits the y-axis, because that's not really what the reality of this situation is telling us. Well, here's what we do know about this line, though. We know that its slope is $0.1 per minute. That's equivalent to 10 cents per minute. And there's one other thing that we know, even though it's a little hard to see here. We know one point on this line. We know the point 100, 30. We know that if we talk for 100 minutes, the cost is going to be $30. So we know the slope and one point on the line. In the past, you've mostly dealt with slope-intercept form, which is a useful way of writing the equation of the line if you know the slope of the line and its y-intercept. Today, you're going to learn two more ways of writing the equations of lines. The first is point-slope form. It's a way of writing the equation of a line when you know the slope and one point on the line, hence its name, point-slope form. The general way of writing point-slope form looks like this. Y minus y1 equals m times x minus x1. M is the slope of the line, and x1 and y1 are the x and y coordinates of one point on the line that you know. This example should help you see how to use point-slope form. Suppose a problem said, write the equation of a line that has a slope of 4 and passes through the point 1, 3. What do we know in this problem? Well, we know that the slope of the line is 4, so m equals 4, and we know one point, 1, 3, on the line. We're going to call the x-coordinate of the one point we know x1, and the y-coordinate of the one point we know y1, and then we're going to plug in what we know. We know m, x1, and y1 into point-slope form. So the equation on the right shows you the general point-slope form of the equation of a line. We're going to replace the y1 with a 3, because on the left you'll see that the y-coordinate of the one point we know is 3. We're going to replace the m in the equation with 4, because it told us in the problem that the slope of this line was 4. And we're going to replace x1 with the number 1, because you see on the left that the x-coordinate of the one point we know is 1. Here's the good news. This is all you need to do. You don't need to solve for y, you don't need to apply the distributive property. You can leave the equation of this line just like it is. This is the equation of a line in point-slope form. Okay. Unless a problem tells you to convert from point-slope form to some other form, like slope-intercept, you can just leave this equation alone. When you wrote the equations of lines in slope-intercept form, it was very easy for you to just look at the equation and to quickly find the slope and the y-intercept of that line. Something similar is true in point-slope form. So I want to know, if I have the equation of a line written in point-slope form, what information can I just quickly see by looking at that equation? Well, if I have an equation like this, y minus y1 equals m times x minus x1, right away there's two things that I can tell. This line has a slope of m. That number out in front of the parentheses, that's the slope. And this line includes the point x1 and y1. We know one point on that line. Let me go through some examples with numbers. Here's the equation of a line in point-slope form. Y minus 3 equals 1/2 times x minus 2. Right away, just by looking at this line without having to do any calculations, you can tell that the slope is 1/2. You'll also be able to tell that the point 2, 3 is on the line. Similarly, here's another equation. Y plus 4 equals 2 times x plus 5. I suggest, so that you don't mess up your positive and negative signs, that you rewrite this equation into point-slope form. Notice the point-slope form is y minus y1. So let's rewrite this equation. Instead of y plus 4 on the left, let's make it y minus negative 4. And instead of x plus 5 on the right, we'll make it x minus negative 5. This will let us very clearly see what the slope and one point on this line are. You can tell that the slope of this line is 2. It's the number out in front of the parentheses with the x. And you can tell that the point -5, -4 is on the line. Notice that by rewriting the equation so that it was y minus something and x minus something made it easier to pull out the coordinates of that one point on the line. So let's go back to the question that started out this lesson. What is the equation of this red line that represents the cost of a cell phone plan? Again, let's remind ourselves of what we do know here. We know that the slope of this line is 0.10, that's 10 cents or 1/10 of a dollar per minute. And we know that the point 100, 30 is 1 point on this line. When you talk for exactly 100 minutes, your cost is $30. We can very quickly write the equation of the red line using point-slope form. And here's what it's going to look like. Y minus 30, 30 is the y coordinate of the one point we know, that's y1, equals 0.1, that's m, times x minus 100. 100 is the x coordinate of the 1 point we know, that's x1. So very quickly, without having to do anything funky, we've written the equation of the red line above in point-slope form. It's important to me that you understand that there are connections between all the different random formulas that you're learning. So the slope formula and slope-intercept form and point-slope form. And what I want to do is take you through a quick example to show you how you get from something you already know, like the slope formula, to something you've just learned, like point-slope form. So suppose I said, find the equation of a line with a slope of 0.1, which passes through the point 100, 30. This is the same problem as you just finished on the previous slide. Instead of dropping these into point-slope form, I'm going to start with the slope formula. Remember that the slope of a line can be written as y2 minus y1 over x2 minus x1. And then here's what I'm going to do. I'm going to notice that x1, y1, and x2, y2 are just 2 points on the line. I'm going to let x1, y1 be the 1 point I know, 100, 30, and I'm going to let x2, y2 stand for any other point on the line. Could be any point, any x and any y. Let me plug in these two things, that x1, y1 is the 1 point I know, and x2, y2 is any other point on the line. I'm going to substitute the slope, 0.1, from the problem into the equation above. I'm going to substitute x1 and y1 into the formula above. And I'm going to substitute just plain old x and y for x2 and y2. All I'm doing is taking known information and substituting right in the slope formula. Then I'm going to multiply both sides of this equation by that denominator, x minus 100. And here's what I get. On the left-hand side, when I multiply both sides by x minus 100, I get 0.1 times x minus 100. And on the right, I get y minus 30. Remember, if you look at this equation sort of facing the other direction, y minus 30 equals 0.1 times x minus 100. This is point-slope form. Point-slope form of a line comes from the slope formula. It's just another way of writing or rearranging the same information that we already have. It's important to me that you guys understand that these different ways of writing the equation of a line are all connected, and you can fairly easily get from one to the other. Now is the time for you to jump in and start your homework for section 5.3. After you've worked on it for about 20 minutes, you want to listen to the PowerPoint for section 5.4.